Hello, everyone. Continuing our English hour. This is Opan in English for all of you. It's fantastic. We are going to talk about something which I think is really pivotal and places vector search in the context of a user-centric perspective. And we have to start this by really discussing a foundational statement that users, regardless of who that user is, deserves better. They deserve better search. They deserve better experiences on our applications and on our sites. In fact, when we talk about users, we are often those users. Anytime you have tried to search on an API reference doc or in a developer documentation site and you knew that there was this method and it did something. I can't remember exactly what it did, but I know I need this method and you're trying to search for it. I don't know about you, but I've had that frustration once in a while. And I'm trying to find the thing and I just can't find it. So when we talk about users, we're not just talking about those people over there, those Luddites, our Sabas and Saftas. We're also talking about ourselves all too often. And we need better experiences too, because so often search is broken. So my name is Ben, and I'm a senior developer advocate at Couchbase. You can find me on all things social at my two favorite things in the world besides my family, hummus and Ruby on Rails. I'm an old Ruby developer, I can't help it. So hummus on Rails, because if it's on Rails, it's even better. So you find me on all things on hummus on Rails. Well, all of these things start with a roadmap. So what is our roadmap for the next few minutes together? We're first going to talk a bit about what vector search is. We're going to run through that. I have a feeling some of you in this room may already know what that is, but if you don't, we're going to go through it anyways. We're going to talk about how it integrates with Gen AI. We're going to share two real-world case studies of impact and close with some grandiose statements around what the future may be, equally ambitious and equally ambiguous. You ready for some ambiguous, grandiose statements at the end? I know you love them. Okay, let's get going. We all begin where everything on the web begins. It begins with a search bar. And let's say you forgot and you lost that recliner you just moved. And you love that recliner chair you had, and you want to find it again. You knew that it was brown, but not too brown. It was kind of like an earthy brown. It reclined, but didn't hurt your back. It didn't recline all the way, and that's what you search for. And what you get? Well, you get chairs. Some of these chairs are even brown. They're not reclining chairs. Not a single recliner, my friends. This may sound humorous, but you know the stakes couldn't be any higher. In fact, the stakes are absolutely huge because nearly 90% of users will not come back to your application, to where you work, the things you build, if they have a bad experience. You know how long it takes to have that bad experience? You know what the typical length of time is before they decide this really is not a great place to be? Oh, that's short. He said 2 seconds. Wow, you're really judgmental. It's good to know. Actually, about 12 to 14 seconds. I heard somebody say 12 seconds over there. Between 12 to 14 seconds, so a little less judgmental, but equally judgmental. You have about 12 to 14 seconds from the time they put that in the search bar to when they decide whether you're effective or not. So the stakes are huge. The stakes are huge. Well, what is this thing that we call vector search? A lot of you probably know already, but even if you don't, and even if you do, a little review is not the worst thing in the world. Vector search is essentially a three-step process in this context. We transform the search queries into vectors. We understand through that vector embedding the semantic context of the user query. Our last presenters talked about brilliantly around human conversation, the way human speech is different and all the ambiguities around it. That's critical. And then we find similar documents. That's essentially what it is. Now, what's a vector? Well, I bet everyone in this room knows what a vector is. For those of us like me who are just back-end developers who need to learn this thing and had to learn all these weird words, a vector is basically an array of floats. And once somebody said to me, Ben, a vector is just a list of floats. I'm like, oh, okay, I get it now. All these other fancy words, but that's what a vector is. It's a list of numbers. And those numbers, each one of them represents vital information about the data that it represents, right? And that data can be text, can be image, can be audio, et cetera, et cetera. Now, these lists can be huge, right? We talk about them being 1,500 dimensions, 2,000 dimensions. The dimensions represent the size of those lists. Very, very big lists. That's what a vector is. And we take any document, in our example, an API reference, and we turn that API reference into a bunch of numbers. That's really cool, but that also sounds a little magical. What's the magic behind taking words and putting them into numbers? Oh, Talia, you're brilliant. It's like you have a master's in this or something. It takes, the magic rests in what we call an embedding model. So we take the query, we take the search query, we pass it through this thing in the middle, and it outputs for us numbers. What are these embedding models? I bet many of you work with them on a daily basis. And one of them, I'm going to mention in just a moment, I'm sure every single person in this room has heard of. But first, embedding models are a type of neural network. That sounds really cool. And you don't even need to be a psychologist or a psychiatrist to understand this. Essentially, our embedding models do a lot of what we do on a daily basis. In fact, right now in this room, I bet a lot of you are doing what an embedding model does. You're listening to me talk, and you're making connections between what I'm saying and other things. You're making connections between what you're hearing, and maybe I remind you of a stand-up comedian from New York. Maybe I remind you of some other thing you heard about vector search somewhere else. Maybe you're thinking about that lunch you just ate and how it reminded you of a great hotel stay you had somewhere in the Dead Sea. You're just having all these connections are being drawn. That is what these embedding models do. They are mimicking your experience. They're mimicking your brain in that capacity. Pretty incredible. Now, one of them, as I said, I would be highly doubtful if no one in this room, if there was a single person in this room that has not heard those three letters, GPT. How many times a day do you use ChatGPT? 1 time a day? 2? 4 or 5? Okay, that's great. You could also say 7 to 10. Your managers are not going to listen, don't worry. Use ChatGPT quite a lot. What does the GPT stand for? Generative Pre-trained Transformer. Essentially, it is exactly what it sounds like. It generates text. It's pre-trained, and your data that you input into it goes through a number of transformer layers to auto-regressively predict what's next. What does auto-regressive mean? It means it predicts based on what was behind it, what will come forward. So if you have the example, the quick brown fox, well, ChatGPT, if you're asking what the next words may be, it may say, the quick brown fox jumped over the whatever. Jumped over the Lamborghini, for example. All kinds of wonderful things. That's only one example of an embedding model. Do you know there's a lot of embedding models out there? Some of them are really popular, and some of them are not so popular. Some of them are used all the time, and some of them kind of just exist in academia. GPT is probably one of the most famous, if not the most famous one, of anyone in the world today. Would not know what this is, but probably have heard those letters. And what they help us do when it comes to vector search is it helps us measure the similarity of data to each other. And we do that by taking the data sets the vector embeddings, the data sets, and doing something called similarity measurements. You know, just like embedding models, there's many, many types of similarity measurements. Cosine, and you know, a lot of them are Greek. Right? It sounds like a lot of Greek words here, cosinus, cosine, Euclidean, etc. One of them, which is one of my favorite, so you probably know this already, right? You take a search query, the way it works, you take a search query, for example, my brown recliner, and then you find the clusters of embeddings related to chairs, and then in there, the subcluster related to recliners, and the subcluster related to brown recliners. and you return back results that actually matter to the user. The way that works, one of my most favorite ones actually, is because it's pretty simple for me to understand at least at a elementary level, is dot product. And I tried to distill for you, now caveat, I did not distill this with the help of ChatGPT, so if it's incorrect, you can't blame ChatGPT. I tried to distill for you into full bullet points how dot product similarity actually works. Why was that important for me to do? Because as I mentioned, I'm not a data scientist, I'm a back-end developer. I needed to understand these things from my context and how I could build with them. So it's basically just math. Or as the Brits say, maths. It's in the plural, I don't know why, but it's basically just math. That's all it is. Taking some math, the higher the number, the greater the similarity, and et cetera, and onwards and onwards. So how does this all work, and how is it relevant to what we want to do when it comes to generative AI? Well, it all boils down to 3 letters, and we've talked about these 3 letters innumerable times in this day. I lost track how many times I heard these 3 words today. How many times, Avner? 10 times, 20 times, 50 times, 100 times? Retrieval augmented generation. We cannot state how important this is to so much of what we're building. But we often don't talk about when we should use these things. We talk often about what it is, but not necessarily when we should use it. So as we know, what does retrieval augmented generation allow us to do? It empowers our agents to be accurate. At the end of the day, who has ever used a chatbot from a year ago and tried to get results and copied and pasted with results into their code and discovered that method they wanted to use in that SDK didn't even exist? But maybe actually that method was a good idea. So maybe I should build that method and open a PR with it because it's a really good idea. That was my experience with chatbots on developer docs forever. RAG helps you achieve more accuracy with the things you build. Essentially, the 3-step process is the vector search, find the similar documents, and augment with that context your agents. That's the 3-step process, al regel achat, like betilo. 3-step process. And the way it helps is obvious. Suddenly, you can ask a bot on a developer documentation for help, and you can almost always be guaranteed. Now, this is the warning, you cannot be guaranteed. It's not that it will hallucinate never, it's that it will hallucinate a lot less. You should always check. Don't do like I've done in the past and did a check and pushed, don't talk about that now, I need therapy for that. But don't do what I've done in the past. Check it. But you'll be more likely than not to get accurate results. That is foundational, and honestly, it's pivotal in the benefit it provides not only to users out there in the abstract, but to us as people who use it as well. So when should you use these things? We know what they are. Ben, we've heard about this 100 times already. When should we use these things? Well, there's some great moments to use them and some great moments not to use them. Content recommendation systems are fabulous. Have you ever relied upon Netflix recommendation systems to find that 1980s British sitcom that died before it even started, but suddenly everyone likes it now because they watched this thing and it recommended you should watch this British thing from the 80s? That was probably some form of this. Anomaly detection, we're going to talk about it in a moment, and human language processing, understanding the semantics and ambiguities of human language. Exact match retrieval, when you keyword search suffices. My friends, when keyword search suffices, please, for the love of all that is good in the world, just use keyword search. Just stick to it. It is computationally a lot less expensive, a lot less intensive. It's easier to maintain for future developers and future you. In many instances, if it works and it matches the needs of your users, just keep using it. And simple data sets as well. Now, I want to share with you 2 use cases which I think are really cool in the sense of the impact this is having beyond chatbots. Because we often talk about chatbots. We love chatbots. I feel like I'm not that old, although my kids tell me I'm really old. But do you remember the days of when you chatbots were just kind of starting in the on bulletin board systems, BBSs? Does anyone remember a BBS? You look like you could remember a BBS, right? Not that you're that old, but you're younger than me probably, but it's good. But remember BBSs, and you would talk to these chatbots, and it felt so cool. There was one called Eliza, I think, from a long, long, long time ago. Chatbots are in vogue. Kingdom alone. Online fraud. This means Nigerian princes, asking for your donation to get your inheritance. This means Western Union transfers. This means so many of those emails that you ignore cost the British consumers nearly 27 billion pounds a year. That's a lot of shekel. And even some agrot. It's a lot. That's a lot of money. With the help of vector search, Revolut, which is a very large online banking platform, built an open source fraud detection system called Sherlock using vector search, which helps not find what is similar, but find what is not similar, or even a fancier word, dissimilar. Brilliant. Under 50 milliseconds for their 12 million users, which has saved their customers over $3 million. Yes, I put it in dollars, I'm American-centric. Over $3 million in 1 year, and catches 96% of all transactions. Additionally, of course, you can see the full case study there if you want to scan that, including the architectural maps, etc. It's really, really fascinating. I'm going to go over by like a minute and a half because everyone else went over by 10, so it's okay. It's absolutely fascinating. And then the other example is multimedia type of search, disparate media search. So the idea that you can search videos with words. Search videos with words. Pretty cool. Company called CNET, which builds basically video clips for companies to have effective marketing campaigns. You may like this, Talia. Effective marketing campaigns. They have over 500,000 video clips that their customers or other companies can leverage for their marketing campaigns. Their customers can search those video clips with search queries and find the right video clip, which is pretty cool, and it does a lot of impact, as you can imagine. Now, you can also see the full case study there as well, including architectural maps, diagrams, etc. Pretty cool. At the end of the day, when all is said and done, all of the progress that we are making, all of the advancement that we are making towards providing users, because at the conclusion of everything, it has to be always remaining focused on our users at the end, which include us, at the end of the day, that what we're marching towards is actually a future of context. And I know we often joke about, well, it depends on the context. Is this right? Is this wrong? It depends on the context. But no, in this case, it really does. It really, really, truly does depend on the context. Because the future for search is going to be contextual. Further understanding the ambiguities of humans. The ways that we speak that are imprecise, the ways that we speak where we use double negatives. I do not like that. Did you like that new shirt I bought, honey? Well, I don't not like your new shirt. It's all the ambiguities of the way that we speak, understanding human search, allowing us to go from more complexity to more clarity. Now, of course, I have to have one pitch. Who doesn't have a good pitch? It wouldn't be a good talk. One last moment, if you do want to learn more, and if you have anyone in your life who is like me, meaning a back-end developer needing to learn these things, coming out in February 2025 is my new book, Mastering Vector Search for Developers, where we walk through how to build a full-stack application using vector search, optimizing with end-to-end testing, etc. It's coming out February 2025. You can sign up for the email list, and you get a nice discount on release date in February 2025 for those on the email list. I highly recommend it. Not that I'm biased at all, but thank you all very much for your time, and continue learning.